Hello everyone and welcome back. My name is Mr. Cobalt and today I will be going over the activity series and using that to explain how you can determine whether a redox reaction is going to be spontaneous or not. And what I mean by spontaneous is, will it happen by itself automatically? So if I put two things together, are they going to react right away without any help from me? Or do I need to put energy into it to get it to react? And that's what we mean by spontaneous. And so, so with regard to the redox reactions, the way that you want to think about this is in terms of how strong the metals are, in terms of how easily they will give up their electrons. So if you have a list of metals here and you're showing that each element, each metal is losing an electron, how easily will that metal lose its electron? So the metals tend to lose their electrons. They want to lose their electrons, but some metals want to lose them more than others. And we call that being more reactive, right? So, and the way, this is your activity series, or this is part of the activity series. This is not the full activity series. But here, it's enough to show you that anything at the top of the activity series is going to be more reactive than anything at the bottom of the activity series. And so, so that means that anything, any metal that's on towards the top is going to be more likely to lose an electron and therefore be oxidized. So elements or metals at the top are more likely of wanting to give away their electrons more than those on the bottom. So how do you know if something is going to be spontaneously reacting with something else, right? So what you want to look at is how far or how high or low they are on the activity scale or the activity series with respect to one another, right? So if you want something to give away electrons, then you got to pair it with something that doesn't want to lose its electrons as much. So, for example, if I put, if I put calcium in a solution of sodium solution, right? So if calcium is higher, calcium wants to lose the electrons more, right? So if I have metal calcium here, let's just say that's metal calcium, and then I have Na plus in solution, well, which one wants to lose electrons more? Well, calcium wants to lose electrons more, but if you've got sodium in here, well, sodium plus already lost its electron, right? But sodium doesn't want to lose its electron as much as calcium. So since calcium wants to lose the electrons more than sodium does, calcium is going to lose its electrons and force sodium to pick them up. So since you've got sodium plus already here, this is going to end up going in the reverse direction. So the sodium plus is going to pick up the electrons and then go to sodium. And so because of that, because calcium is higher, more reactive, more likely to give off its electrons, that's going to be a spontaneous reaction. But if I try to do it with something else, let's say I wanted to let's say zinc metal with aluminum, right? So if I have my solution and I have zinc metal, so in my solution I have, let's say, magnesium 2 plus solution, in there and I put zinc in there. So will this react? So I have zinc metal here is below the magnesium. So magnesium wants to give away electrons more. So it wants to be in this state more than zinc does. So because magnesium wants to give away its electrons and stay in this state more than zinc wants to, then zinc is not going to be able to pass its electrons to the magnesium and make it go into the opposite direction. So in order for zinc to spontaneously react with the magnesium, zinc is going to have to pass on its electrons to Mg2+. But magnesium wants to lose its electrons more, so it's more likely to stay in this state. So when I take zinc metal and I put it into a magnesium solution, no reaction is going to occur spontaneously. So if I want to get this to occur, then I'm going to need to put energy into it. Maybe I need to run electricity through the system, connect it to a battery or something like that, and run electricity so that I can get the reaction to go. But it's not going to happen spontaneously. So the way you can determine whether or not a reaction or a redox reaction is going to be spontaneous is are you pairing up the higher what do you call it? These are oxidation half reactions. So everything is being oxidized or losing electrons. So are you pairing up a higher half reaction with something that's lower, and then with the reverse of the lower? So if you pair the oxidation reaction with a higher half reaction with something with the opposite direction or the reverse direction of something lower, then it's going to be spontaneous. But if you're trying to pair the oxidation half reaction with the reverse of something above it, it's not going to be spontaneous. So that's how you can use the activity series to determine whether or not a reaction is going to be spontaneous or not. So here I have two examples. So here we have solid iron being mixed with magnesium aqueous solution. So I'm going to put the iron in the magnesium solution and supposedly transfer the electrons to the magnesium to get magnesium solid and then the iron 2+ ions. So in order for that to happen, I need magnesium solid to be oxidized. So the only way this is going to work is, in order for this to work, I need magnesium to go in the opposite direction. So magnesium 2+ is going to pick up the electrons and go back to magnesium solid. So where's magnesium? So I need this to go in the opposite direction. So I need iron to go and be oxidized. So where's iron though? Iron is, where is iron? Where did I put iron? I don't find iron here. Maybe I didn't put it down in the book. Iron is after chromium. So zinc, chromium, nickel. Oh, iron. I forgot to put iron. So it's after zinc. It's in between here. So iron is actually here. So iron is down here, and then magnesium is up here. So iron is going to oxidize, but it's below. So if I want iron to oxidize spontaneously, it's lower than magnesium. So magnesium is more likely to oxidize. It's more likely to lose its electrons. It's more of a stronger oxidizer, okay, or it's stronger in oxidizing. It's more reactive. So this would not work because I would need this to go in the opposite direction, and it's more likely to go in this direction compared to iron. So this is not going to be spontaneous. If I take iron and compare it with lead, so lead is down here, So here, for this to work, I need iron to give up its electrons and give them to lead. So lead would have to pick up the electrons and go back to solid. So lead is down here. I would need lead to pick up the electrons and go back to the solid. So it would need to be reduced, to go in the reduction direction. This will work because iron is above, so iron is more likely to lose the electrons than lead. So if iron is more likely to lose electrons, it's going to lose the electrons and pass it to lead and make lead go back to solid. So this is going to be a spontaneous reaction. So this is going to be spontaneous. This is not. So again, in order to make something spontaneous, you need to pair up the oxidation half reaction that is above to the reverse reaction of something below. So, so if you're going to start with a metal, then you need an aqueous solution that is below, that is of a metal that's below it. That's, I guess, another way you could put it too. I hope this is helpful. I hope you enjoyed this and learned from it. You know, if you have any questions, please put them into the comment section. If you like the video, share the video, like it, subscribe to my channel, and hit the notification bell so that way you can get new notifications for any new videos that I put out. Thanks for joining me, and see you next time.